One of the largest hydrological reserves in Spain, Alcántara Reservoir, is located in the north of the province of Cáceres. It formed a natural obstacle to La Plata dual carriageway, and two singular bridges had to be built, one for each carriageway. The reservoir is crossed by 400-meter-long twin viaducts, each of them built with a 220-meter span central deck arch. Construction commenced by excavating the foundations, formed by reinforced concrete footings resting on micropiles, which, apart from transmitting vertical loads to the ground, contribute towards improving the stability of the slate sides. The access area piers rise from the footings and are formed by two rectangular reinforced concrete shafts, finishing in a top cap. The piers are arranged every 26 meters and reach a maximum height of 52 meters above the arch springing. Large foundation blocks supporting the tallest piers and also forming the arch springings are located in the area close to the reservoir. All concrete piers are built with climbing formwork. Each arch rests at its end on a reinforced concrete block, measuring 11 meters wide, 14 meters long, and 10 meters maximum height, taking up a stepped shape where it makes contact with the ground. The vertical reinforcement anchorage of the tallest piers and the set of high-strength steel bars arranged in a sloping position to form the fixed attachment between the metal arch and the foundations are located in its inside. The piers are built at the same time on both sides of the reservoir. Once the infrastructure is finished, the whole of the deck is assembled on dry ground, on the flat area behind the abutments. Each deck is built of two V-shaped Corten steel continuous beams joined by a top reinforced concrete slab. The slab is built on a 26-meter-long formwork tables, moving at the rate of one complete module a week until the deck's overall length is completed. Dry land construction is performed in a simple fashion and enables the deck to be built under optimum accessibility conditions. Half of each deck is built behind each abutment and then moved into its final position using the launching method. A transverse beam is used to push each deck at the back where cables are applied to transmit the horizontal thrust force. The maneuver is carried out by sliding the deck over Teflon bearings placed on concrete blocks 15 meters from each other. The deck assembly's traction cables are operated at their opposite end by abutment-anchored hydraulic jacks. The first 22 meters of top slab were not concreted in order to reduce stresses in the deck in positions where it overhangs during the advance. The launching maneuver is stopped when the deck hangs over the pier closest to the reservoir. Once launching has stopped, a crane is used to remove the first 12 meters of metal beams, so as not to hinder future arch erection operations. The same launching operations and removal of the front metal part of the deck's main beams are repeated on the opposite bank of the river. Each arch is divided into 60-meter-long parts, weighing 200 tons, which are assembled horizontally and moved over the deck with skids up to the front part, where a metal gantry picks it up for the advancing, overturning, and lowering operations until connecting with the previously placed bottom piece. The gantry is fitted with moving elevation and retaining mechanisms, formed by hydraulic jacks operating vertically arranged cables. The next quarter archer is then carried over the deck until connecting with the previous part in an area provided with hinges. The second quarter arch is then hoisted and overturned with the use of a crane until reaching a position close to the vertical. Vertically acting hydraulic jacks placed on deck-supported steel auxiliary towers are used instead of crane hoisting in order to control movements in the last phase when the second quarter of the arch is rotated. The arch section is then completed by plate welding, whereby the hinges are locked. Each semi-arch in this situation is formed by a 120-meter-long, vertically arranged part ready to be lowered down. The next operations involve metal structures which are joined to the semi-arches by holding cables and are assembled on the deck. Each semi-arch is lowered down by pivoting on the springing hinges, and its movements are controlled with the holding cables. A guide system is fitted at the front of each semi-arch in order to fit them both together and at the same time align them with each other. The lowering operations are performed simultaneously from both sides. Hinge-fitted stops for obtaining a 3-hinged arch are arranged at the front of the semi-arches, and a stable structure independent of the holding cables is thus obtained. The sections are then completed with welded plates, and the hinges are locked. Each semi-arch rotates on hinges arranged on the springing blocks. The hinge support structure is connected to a system of horizontal bars and jacks, controlling the displacement movement towards the reservoir, and each semi-arch's orientation, so that they both match up with each other at their front. When the lowering operation has concluded, the hinges are locked by fitting anchor bars and reinforcements, followed by concreting the area where the rotation mechanisms have been housed. A crane is used to continue the viaduct's construction by erecting the first two metal piers located on the arch. The deck is then launched into a further phase until the second pier erected is reached. The arch is pushed simultaneously from both banks to prevent asymmetric loads in the arch due to the dead weight of the decks. The remaining piers are erected using a crane located at the front of the deck. The last launching phase is performed on both sides until the deck is joined at the structure center. The viaduct is completed with paving, signposting, barrier fitting, and other finishing work. The bridge over the River Tagus is a national and a world landmark in arch building, not only for its size, but for the combination of construction systems and auxiliary resources used. Operations involving deck launching, large part tilting and lowering, lifting and lotating a quarter of an arch, and finally semi-arch lowering were harmoniously linked, thus constituting in itself a world record, since operations of such a magnitude were unknown up to now.